This demonstration is about measuring the relative molecular mass of a gas. The gas needs to come from a source that can be weighed on a top pan balance. We're going to use gas from a camping gas cylinder, but other possible sources are gas used to fill gas lighters. We can improvise a bit of tubing on the end, or even from a disposable gas lighter itself. What the experiment involves is collecting a cubic decimeter of gas and weighing the container of gas before and after collecting it. If we're using camping gas, the first thing we need to do is remove the burner and the pan holder from the cylinder so that we can attach a piece of flexible rubber tubing onto the screw thread at the top. We collect the gas in an inverted measuring cylinder full of water. This inevitably involves getting your hands wet, so it's a good idea to have some tissues available to dry them, because you don't want to get droplets of water onto the canister. Remove the delivery tube and weigh the gas in its cylinder. Replace the delivery tube and place it so as to collect gas by displacing the water in the cylinder. We now collect a cubic decimeter of the gas. Once we've collected a cubic decimeter of gas, we can remove the delivery tube. Make sure there are no droplets of water on the cylinder which would affect the weight. We can re-weight on the top pan balance. You find that something like 2 grams of gas have been used. Using the approximation that 1 mole of any gas at room temperature and pressure has a volume of approximately 24 cubic decimeters, the relative molecular mass of the gas can be calculated simply by multiplying by 24. If required, the pressure and temperature in the lab may be measured and a more accurate value calculated. But this risks missing the point of this simple experiment. Camping gas is in fact a mixture of propane and butane, and if we know the average relative molecular mass, then we can actually calculate the percentage composition of the gas mixture. This experiment enables us to measure the relative molecular mass of a gas by weighing 100 cubic centimeters of it in a syringe. Before the experiment starts, you need to modify a hypodermic syringe, a plastic hypodermic syringe, by making a hole in the plunger through which a nail or a metal rod can be inserted, which will lock the plunger at the 100 cubic centimeter mark. You also need to prepare what we call a gas bag of whichever gas or gases you intend to use. This one is carbon dioxide. This is simply a party balloon which has been inflated with carbon dioxide from any convenient source and sealed with a self-sealing rubber stopper. We first want to weigh, in effect, the syringe plus 100 cubic centimeters of vacuum. Put the hypodermic needle on the end, seal it with a rubber bung, and pull the syringe out. This is quite hard work, to beyond the 100 cubic centimeter mark and lock it with the metal rod. This can then be weighed on a top pan balance, which needs to weigh to 3 decimal places. In effect, we've weighed 100 cubic centimetres of vacuum plus the syringe, etc. Place the hypodermic needle, make sure the plunger is fully in so there's no air in the syringe. Insert the hypodermic through the self-sealing rubber stopper, taking care not to puncture the balloon, and draw in 100 cubic centimetres of carbon dioxide from the balloon. Seal the hypodermic again with a rubber bung. We no longer need the rod, of course, to hold the plunger at 100 cubic centimetres, but we must be careful to reweigh it and reweigh the whole assembly on the top pan balance. We now have the weight of the syringe plus 100 cubic centimetres of carbon dioxide, and the difference, of course, is the weight of 100 cubic centimetres of carbon dioxide. Since we know that at room conditions a mole of any gas has a volume of 24,000 cubic centimetres, we can calculate the relative molecular mass of the gas simply by multiplying by 240. Some students may not see why the syringe cannot simply be weighed with the plunger at the 0 mark to give the weight of the empty syringe. This can be explained by reference to buoyancy, or, more simply, by pointing out that weighing the syringe both times with the plunger at the 100 cubic centimetre mark is a fairer comparison. Select the gases to be investigated with care. The experiment is not suitable for gases of very low density, such as hydrogen. 100 cubic centimetres of hydrogen has a mass of only 0.0083 grams and cannot be weighed with any accuracy even on a 3-figure top pan balance. In contrast, 100 cubic centimetres of carbon dioxide, for example, weighs 0.1183 grams.